time management, and cost management knowledge areas. Here, please note that some techniques may be used also in other knowledge areas such as risk management or even in scope management. After defining and sequencing the activities, resources required for each activity are identified. Once the resources are identified, the next step is to estimate activity durations and activity costs. Same techniques are used in order to estimate the durations and the activity costs. In this chapter, we will see all of them. Among the estimation techniques, 3-point estimation is the most important one, therefore, we will go in deep to this technique. Please note that in this chapter, we will not mention about reserve analysis since we will have a separate chapter for this technique. At the end of the chapter, you will find sample questions which are designed to solidify your knowledge, so don't forget to solve all of them. Duration and cost estimating techniques. In order to better control the project, a project manager has to know estimating techniques. With these techniques, cost and duration of each individual activity is identified. Let's start to learn them one by one. One-point estimating technique. As it's understood from the name of the technique, only one estimate for each activity is submitted by the estimator. Estimation may be based on historical data, expert judgment, or even a guess. For example, excavation of the construction site will take 10 days. Here, we make only one guess for the duration of the excavation activity, which is 10 days. This is an example of one-point estimating. Analogous estimating technique. Analogous estimating technique may sometimes be called as top-down estimating technique. Historical information is used in order to estimate a project's cost or duration. Note that it may also be used for cost or duration estimation of individual activities. Expert judgment is required in order to estimate. This technique is a fast estimating technique, but it gives less accurate results compared to parametric and 3-point estimating techniques. Therefore, for this technique, we can say that fast but less accurate. Let's give an example in order to better understand. Last year, we constructed a building in 11 months. This year, in another city, we will construct a building similar to that building. Therefore, total duration of our new construction will be 11 months. In this example, we estimate the project's duration by looking at the duration of the past project, which is similar to our new project. Here, please note that the key word is similar. In order to predict by using analogous estimating, the past project or activity should be same or similar to our new project or activity. This is important. If the similarity increases, the accuracy of the prediction also increases. 3-point estimating. In one-point estimation, you just say that this activity will take 10 days to finish. But what if everything goes wrong? Can you still finish it in 10 days? No. You will finish it, let's say, in 14 days. Or let's think the opposite. What if everything goes very well? If everything goes very well, then you will finish it earlier, let's say in 7 days. So, how can we make better estimations so that our estimate covers the probabilities of everything goes wrong, everything goes well, and as well as most probable estimations? Aim of 3-point estimate technique is to cover all these probabilities. Therefore, 3-point estimates are used in order to get more realistic estimations. Here, let me remind you that, just like the other technique, this technique is also used for both duration estimations and cost estimations. We use three estimations in order to calculate the more realistic estimation. These are optimistic estimation. This is what if everything goes well scenario. This is abbreviated as O. Most likely estimation. This is most likely we will finish it, or most likely cost of this activity will be scenario. This is abbreviated as M. Pessimistic estimation. This is what if everything goes wrong scenario. This is abbreviated as P. Generally, calculation for two distribution types is done for estimating. These are triangular distribution and beta distribution. For both of the distribution types, we use all optimistic, most likely, and pessimistic scenarios. Triangular distribution. If you see the terms like simple distribution or straight distribution, please note that both of them are telling you that this is a triangular distribution. First, let me explain why this distribution type is called triangular distribution. You don't need to know this for PMP examination, but you can better understand the concept this way. This is probability density function chart. You don't need to know what probability density function is. Just know that the probabilities of all of the estimations occurs in a manner so that its shape looks like a triangle. This is why it is called triangular distribution. The only formula you need to know for triangular distribution is expected activity duration or expected activity cost equals to sum of pessimistic, most likely, and optimistic estimations divided by 3. Or by using abbreviated terms, it is P plus M plus O divided by 3. I will explain another term, standard deviation, in beta distribution lecture, but here I would like to note that standard deviation formula for triangular distribution is so complicated and you don't need to know it for PMP examination. Let's give an example. Pessimistic duration of an activity is 14 days. Optimistic duration is 7 days. And most likely duration is 9 days. What is the expected activity duration? Here, we will enter the values in our formula. Our pessimistic duration is 14 days, therefore P is 14. Most likely duration is 9 days, therefore M equals to 9. Optimistic duration is 7 days, therefore O equals to 7. 14 plus 9 plus 7, which makes 30, divided by 3 gives us the result of 10, which will be our expected activity duration. Beta distribution. Before starting to the lecture, please note that in the exam, if you see either weighted average or PERT terms, then the question is talking about the beta distribution. In the previous lecture, we see that in triangular distribution, probabilities occur in triangular manner. In beta distribution, it's most likely a bell shape. You need to know two formulas in order to answer the questions in PMP exam. First one is the expected activity duration or cost formula. Expected activity duration or expected activity cost equals to pessimistic estimation plus 4 times the most likely distribution plus optimistic estimation divided by 6. Or with abbreviated terms, P plus 4M plus O divided by 6. Let's solve an example. Pessimistic duration of an activity is 14 days. Optimistic duration is 7 days. And most likely duration is 9 days. What is the expected activity duration if the distribution is assumed to be beta distribution? This is the same question we solved in previous lecture. But this time, the distribution is assumed to be beta distribution. Again, we will enter the values in our formula, but this time we will use the formula for beta distribution. Our pessimistic duration is 14 days, therefore P is 14. Most likely duration is 9 days, therefore M equals to 9. Optimistic duration is 7 days, therefore O equals to 7. Our formula for beta distribution is P plus 4M plus O divided by 6. If we calculate it, it will result as 9.5. Remember, we found this result as 10 in triangular distribution. Since the result is differing by the type of the distribution, you need to memorize both of the formulas. Second formula you need to memorize for beta distribution is the standard deviation formula. Standard deviation equals to P minus O divided by 6. Here, again, P is pessimistic estimation and O is optimistic estimation. Okay, we saw the formula. But what is standard deviation? What does it tell us about the estimation? Let's discuss. In the first formula in this section, we saw the formula for expected activity duration or cost. Standard deviation is the range of possible activity durations or costs may occur. Therefore, range of estimation is in between expected activity duration or cost minus standard deviation and expected activity duration or cost plus standard deviation. For example, if expected activity duration EAD of an activity is 10 days and standard deviation is 2 days, we understand that although we expect the duration is 10 days, it may be resulted in between a range of 8, which is 10 minus 2, and 12, which is 10 plus 2. Okay, what happens if standard deviation was greater? If standard deviation is greater, this means our possible range for estimation is greater. Therefore, the possibility of not to finish with expected activity duration is greater. This means our probability of finishing the activity in expected time is less, which makes our estimation more risky. Therefore, we can say that greater standard deviation means greater risk. Okay, let's go to back our example again. Pessimistic duration of an activity is 14 days. Optimistic duration is 7 days. And most likely duration is 9 days. What is the standard deviation? Before solving the question, please note that in the PMP exam, if distribution type is not mentioned in the question, always assume that this is a beta distribution. Since in our example, it doesn't mention about what type of distribution we should consider, then we will assume that this is a beta distribution. Let's remember the formula again. Standard deviation equals to pessimistic estimation minus optimistic estimation divided by 6. Since P equals to 14 and O equals to 7, if we put the values into the formula and do the calculation, the result will be 1.17. Let's ask another question. What does it mean? Remember, we have calculated our estimated activity duration in the previous example as 9.5 days. Since we just calculated standard deviation is 1.17 days, this means possible range for our expected estimation is 9.5 plus minus 1.17. Therefore, possible range of estimation is in between 8.33, which is 9.5 minus 1.17, and 10.67, which is 9.5 plus 1.17. So, although we expect the duration as 9.5 at the end of the job, it may result in between 8.33 days and 10.67 days. This was the end of activity duration and cost estimating chapter. In order to solidify your knowledge, please solve the sample questions. And after that, solve the realistic exam questions in quiz format in order to perfectly be ready for the PMP exam. Sample questions. Question number 1. Among the estimating techniques followed, which technique strongly needs historical data of a similar project? A. One-point estimating. B. Analogous estimating. C. Parametric estimating. D. Three-point estimating. Which one do you think? Answer is B. Analogous estimating. In analogous estimating, we strongly need to have historical data of a similar project. Don't forget, in analogous estimating, the project should be similar so that we can predict our estimation. Question number 2. Which one is not a disadvantage of one-point estimating? A. It does not give accurate results compared to other estimating techniques. B. It may result padding. C. It is one of the slowest technique among others. D. It does not consider the risks and uncertainties. What do you think? The correct answer is C. All other three are disadvantages of one-point estimating technique, but since only one estimation is done and no calculations are made in order to get this estimation, this will result faster estimations than parametric and three-point estimating techniques. Therefore, it is not the slowest estimation technique. Question number 3. What is the expected activity cost if worst case scenario estimate is $9,000 best case scenario is $5,000 and most likely scenario estimate is $6,500,000. First of all, we need to know what type of distribution is. Okay, here's the trick. In the PMP exam, if it does not tell anything about the distribution type, always assume that it is beta distribution. If we go back to our question again, since it doesn't tell anything about the distribution type, we assume beta distribution. Let's remember the formula for beta distribution. Expected activity cost equals to P plus 4M plus O divided by 6. For this question, since worst case scenario estimate is $9,000, P equals to $9,000. And since best case scenario estimate is $5,000, O equals to $5,000. Since most likely scenario is $6,500,000, M equals to $6,500. If we enter the values into the formula, we get the result and the answer is C. Question number 4. What is the expected activity cost if worst case scenario estimate is $9,000, best case scenario is $5,000, and most likely scenario estimate is $6,500,000? Assume triangular distribution. Well, the estimations are similar to previous question, but this time in the question it says that this is a triangular distribution. Let's first remember the formula for triangular distribution. Expected activity duration equals to P plus M plus O divided by 3. If we put the values into the formula, we get the answer as A. Question number 5. What is the activity standard deviation if worst case scenario estimate is $9,000, best case scenario is $5,000, and most likely scenario estimate is $6,500,000? Well, since it doesn't tell anything about the type of the distribution, then we will assume beta distribution. Let's remember the formula. Standard deviation equals to P minus O divided by 6. Here, please note that we don't need most likely estimation. This is unnecessary information. Let's enter the values into the formula. We get the answer as B. This was the end of the activity duration and cost estimation chapter. Please solve the following realistic exam questions in order to perfectly be ready for the PMP exam. Thank you.